right, we're going to look at lesson 13.1. We're going to look at scatter plots and fitted exponential curves. All right, we're going to start with task 3, which is using technology to find these models. So we're going to skip task 1 and 2, which shows you how to do these by hand. And based on our standards, we don't need to be able to do this by hand in Algebra 1. We're just going to skip and make sure that you know how to use your calculator to find these. All right, so let's get started. Model exponential data using technology. Exponential regression is a statistical method used to fit an exponential model to a set of bivariate data. You can use a graphing calculator to find an exponential growth or decay model for the data. Use the exponential regression feature on a graphing calculator to find and interpret an exponential function that models the aquarium visitor data from task 1, shown in the table. All right, so even though we didn't do task 1, we are given this table of values here, and we're going to use our calculator to look at the data. All right, so the first thing I want you to do is go to STAT, stat. All right, when you click on stat, you're going to click on number 1, which is edit, and you're going to enter the data. You can see that I've entered the time, T, in years since 2010 in L1, and I've entered the visitors in thousands in L2. So I went ahead and entered that to save a little bit of time. But I want to show you, after you enter that data, you can do second quit. It saves the data in there. And I want you to go to second catalog and scroll down to diagnostics on. Okay, and at any point, if this is going too fast, you just need to pause it, catch up, and then continue. All right, so click on diagnostics on, and then you're going to hit enter to where it says done. All right, it has to say done before it turns it on. Now, diagnostics on is going to add the r and the r squared to our equation. So when we go back to stat, this time we've already entered our data. So if I hit enter, you're going to see the data is already there. So if I hit stat and go over to calculate, now I'm looking at an exponential regression. So I'm going to scroll down to where it says exponential regression. And then I'm going to click enter. And I enter through that. And then I get A, that's my initial value. My y-intercept is 250.2388938. And B is my growth rate. It's growth because it's greater than 1. So B is 1.194275047. R squared is 0.997 and R is 0.998. Now remember the R and the R squared. So the closer this is to 1 or negative 1, the stronger the data is to the model that we have written. If it's closer to 0, then there's no correlation between the data and the equation that it's been written. So this has a very strong correlation. So let's see what this says. All right, so it says enter the data points from the table to create the scatter plot, which we did. And our data is going to be similar. I can go to y equals, clear out my old equation, and then if I go to vars 5 equation, it's going to copy the equation that I just wrote, and then I can hit graph. Now, my window is not the same as this window, but you can see from nothing's going to show up here because I don't have my window set correctly, and it looks like it didn't graph, but my X or my T is going to go from 0 to 5, and my Y values start at 250 and go to 610. So I'm going to have to expand my window, and you can see that they go from 0 to 6 and from 0 to 600. So we're going to have to change our window. So change window, and my X's you have to have a negative number here, so I'm going to put just -1. And then my maximum value, I'm going to put 6. And then that's a scale of 1. You can see these go 1, 2, 3. And then my y values, I'm going to go from -1. Has to have a negative number there for a minimum. And then I'm going to go up to 600. So I need to go to something bigger than what's in the table. The table says 610, so maybe I'm going to go over here and click 700. At least 600. 700 wouldn't hurt. Okay. All right, and then it says, what do you want your scale to be? If you're going from 0 to 700, if you go by ones, it's going to be really tiny and hard to see. You can see here they're going by 100s. So let's go by 100s as well. And then if I hit graph, my equation's already in there. We just couldn't see it because the window wasn't at the right spot. So if you change your window, now this graph should look similar to this graph. All right, so let's see what it asks us. It says, what viewing window and scale let you see the relationship clearly? Adjust the window to show t from 0 to 6. Remember, t is on your x-axis. And the y value from 0 to at least 600. They're going from 0 to 700. Use the scale of blank for the major grid line on the t. So on the t, we're going to use a scale of 1. And a scale of what for the major on the v-axis. So on this axis, we're going to use a scale of 100. All right, and again, you change the window so that you can see what you're doing there. So it says, in your graphing calculator, if your graphing calculator offers the option of log mode, select it. All right. In my calculator, if you go to mode, there is no log mode, so don't even worry about this right here. It says there's different ways to perform exponential regression, and choosing log mode will perform a regression in a way that gives you a correlation coefficient R that helps you assess the goodness of fit, just as with a linear regression. All right, but we did the linear regression. If you have a TI-83 or 84 model, you're going to do it the way I showed you how to do it. All right, an equation for the exponential model is 250 point this times 1.19428 raised to the t power. And if you go back to, well, let's see, I lost it, so I'm going to calculate it again. Remember, my points are in there, so if I hit exponential regression again, it's going to calculate it. And the 250.239 comes from right here, and the b is 1.19. That comes from right here. So y equals a times b to the x power, exponential. Remember, x is always going to be the exponent, and this gives us our a and b, and then r tells us how strong a correlation it is. So it says, what do the initial value a and the base b of the function represent in this context? Select all that apply. All right, so remember the bottom was t in years since 2010, and up the side was population in thousands. So it says the number 250 represents the growth factor in attendance each year. The number 250 represents the attendance in thousands at the aquarium in 2010. So this is a more specific answer. So it's this one here. And then it says the base represents the growth factor in attendance each year. The base represents the attendance in thousands at the aquarium in 2010. All right, so the base, the growth rate, doesn't have anything to do with the year. So it's going to be this one here. All right, so the correlation coefficient, R, equals 0.9989, which indicates an excellent fit for the model to the data. That means the equation that our calculator wrote is an excellent fit to the points given. So the model itself indicates the attendance at the aquarium is increasing at an annual rate of 19.4%. The average rate of change on the interval from 0 to 2 is what? All right, so if we go up here and look, remember the average rate of change is your difference in y's over your difference of x's. So 350 minus 250 over 2 minus 0. And the average rate of change from 3 to 5. So if we do the average rate of change from 3 to 5, we're going to have 610 minus 420. 610 minus 420 and 5 minus 3. So these average rate of change means that the growth factor is, well, it's increasing and it's not constant. All right, where does the rate 19.4% come from? Enter the correct number to complete the sentence. All right, so the interest rate comes from subtracting 1 minus your growth factor. Remember, B is always 1 plus or minus R, your interest rate. And since this is 1.194, you can assume that it started with 1 and the interest rate is the 19.4%. Remember, going from a decimal to a percent, you always move it 2 decimal places. So that's how this became 19.4. All right, so after rounding the converting to a percent, the rate represents the increase in attendance each year. All right, so that is all for task 3. If you have any questions, please let me know.